stop talking and listen to my calculus project on Euler's number. Here it goes.
It is I, John Napier. While I was researching logarithms in 1618, I described the constant in a table at the end of my study. Therefore, I discovered it.
Everyone knows you didn't write that table. William Ottrell did. Besides, I, Jacob Bernoulli of the famous Bernoulli family, in 1683, was the first to approximate the value as a limit. While I was studying compound interest.
Bernoulli and Napier can fight all they want, but the number was named by me. After all, it is called Euler's number. Although, technically, the E is not for Euler. I probably was making E short for exponential, or it was just the next vowel, since I used A with other calculations. I can't remember. Basically, in 1731, I proved Bernoulli's limit is equal to E, and found all kinds of special properties about it. I even approximated E to 18 whole decimal places. And now, what do we do with this number? We use it, of course, in many different ways. I'd say, one of the most important properties of E comes from the equation y equals e to the x, which is called the natural exponential function. Obviously, the graph is important because the slope of e to the x anywhere is e to the x, which is why the derivative of e to the x is e to the x, or e to the x grows at a rate equal to its value. Nicely explained. The same is true for the area. The area between e to the x and the x-axis to any x value is e to the x, which is why the integral has the same rule. You see, when e is involved in exponential equations or the base for a logarithm, life is so much easier. That's why we appreciate e so much. You may be asking for the real-world application for e. Of course you are. We'll let Bernoulli handle thought.
Hello. Ooh, please. There are so many applications. Have you heard of statistics? Of course you have. That's probably where you know me from. Well, in statistics, say, if everyone brought a plunger to this bathroom, and everyone selected a random plunger to take home, all the permutations of who would get what plunger divided by the number of possibilities, where no one gets the same plunger as they originally brought yields E, finance too, if you care. When interest is being continuously compounded, we can just rely on my trusty limit to compute your interest. E to the x and its unique properties are used in models everywhere. In biology, population models. In chemistry, radioactive decay. In physics, thermodynamics. It goes on and on.
Hopefully, you see now why E is such an important number to calculus.